And we are going to start with color. And I think I'm going to start in the back and we'll kind of work our way around. So if we can get Clara, can you tell me what you have for the definition of color? All right, perfect. If that's what you have, that's what you need. Because color isn't whether or not things are red, blue, green, yellow, orange. That's how we perceive color. But what color is wavelengths of light. Because light doesn't just come in one size. We have smaller waves. We have longer waves. And depending on the size of wave that gets reflected off of stuff and go into our eyes, our brain turns it into a color. So all that's really there is light waves of different sizes. And they bounce off of stuff, and your brain turns them into colors. For example, this blue shirt or my blue cupboards, a small wavelength of light gets reflected off, and when the small waves go to our brain's like, okay, I'm going to make that blue. When we have something that's yellow, longer wavelengths bounce off of it, and when those longer waves go to our brain wants some more variety, so it turns it into yellow or sees it as yellow. When we have, where's something red? I've got my red spray paint. This has the longest wavelengths that our brain is able to process. So when those longer waves reflect off of this cap, or his shirt or anything else that's red, that longer wavelength, our brain turns into red. And that's kind of what that second resource talked about, is how we actually see color. So yes, that means color is in your imagination. It is completely created in your head. All that's real is different wave sizes reflecting off of stuff. But our brain wants more variety, so it assigns color to things, or to different wavelengths. Yes?
So, like, theoretically, like, someone's blue could be another person's red, or that's how our eyes like.
Yes.
That is so good.
Yes, because what happens when you're a kid, you see that and you get trained to call that blue. But what you're actually visualizing inside your brain, could that be a little different than what someone else is visualizing in their brain? So that could be different, like, because it's all in your head. We just know when you see that and what your brain does with that wavelength, we've been trained to call that blue. We've been trained to call that black. We've been trained to call this orange. So exactly what's in your brain and what your brain is seeing might be a little bit different than what other people's brains are seeing. Good question.
Is that what color blindness is?
That's
Yeah.
what I was going to say.
So color blindness, and there's a variety of color blindness, but the full color blindness where you just see everything black and white, by the way, they see the world more the way it really is, because the real world is black and white, light reflecting off of things or not. So most typically color blindness, the back of your eye has receivers for the different wavelengths. And most often, those receivers are either missing or they're not functioning in making the distinction between the different wavelengths. So you don't get the message sent to your brain, this is a short wavelength, this is a long wavelength, it's just there's this much light or not light. So that's the most common for colorblind. There is red-green colorblind. That's very common in men because it's on the DNA that, anyway, so it's more common in men. Why? It's kind of a genetics thing that you'll get a lot more in biology. But that's where your brain gets the message for different wavelengths of all the colors except red and green. Your brain processes it as if it's the same color. Even though green wavelengths are shorter and red wavelengths are longer, your brain processes them as the same.
Why does it do that?
It has to do with the receivers and the message being sent because of, just the genetics in the receivers being formed based on the DNA.
So going along with that, there's like this trend where people will see something as a different color. Is that how it works? Where people will just perceive it differently?
Yeah, that's a lot of it. Sometimes it has to do with the computer screen or TV screen you're seeing it on. So sometimes that's the difference, which people that are in graphic design, they've got these huge charts for what the actual color is, like when it's printed or on that kind of stuff, because screens and what creates the light in screens might have variation. So sometimes it's explained that way. But the other thing is it does have a lot to do just with how your brain processes and perceives the color. So, excellent question. All right, so now we know what color is and how we see it, but now we're to the so what. How is that actually useful in making stuff to sell people or to be handy in society? And this is where I'm going to go ahead and take some volunteers. Were there any that stood out to you guys when you looked at the 22 intriguing facts about colors? Any of those that would tie to products?
The color white is used for cars because it prevents accidents.
All right, if you want to have a car that's less likely to get run into, you want a white one. Because in the environment of the road, white is going to stand out a lot more than dark colors will. And so your car will be more noticeable in that road environment. So just that right there is an example that if you want to buy a car that's less likely to be hit by other people in traffic, white's your best bet. There we go, yellow tends to make you feel dizzy or nauseous. And where people tend to feel that way anyways on an airplane, would that be pretty bad? You don't want that getting any even worse in a contained place like that where a lot of people are kind of agitated, right? So color can trigger emotions, not just perceptions of, you know, the colors that we see. All right, so that's a good example. All right, any others? All right, so yeah, traffic signals and signs. Color is what most of us get trained on, especially as you guys are getting ready for driving. People that are colorblind, they have to pay attention to the order. And some stoplights are standing up, some stoplights are turned down, and you notice some stoplights kind of have 5 with them. People that are colorblind have to memorize the patterns for the variety of different lights, so they make sure they're responding to the proper signals that the rest of us take advantage of because of that color. So it definitely gets used, that most people, it's easier to make those distinctions, but for some people, they just have to learn a different format to make sure they're following and being safe. All right, so that's a good one. Were there any others?
I just have to bring this up. If you're born colorblind, wouldn't you get call the colors correctly if you don't see them ever properly?
Wait, so say that again.
If you are born colorblind and you see blue and it looks like it's red, wouldn't you call blue blue since you already think that it's that color?
See, and that's where, if you can see a distinction, we get trained what to call that distinction. So what you're actually seeing could be super different, but if you can tell that distinction, you just get trained what to call it. Kind of like we draw the shape. I draw this shape on the board. What is it? That's arbitrary lines. You get trained that those lines have meaning. So you know that's A because you've been trained. When those shapes get put together, we call it A. Or when we put those together, what do we call it? 4. That means nothing. It's just a pattern that we have assigned something to. Now this has a value of actual 4 dots, right? That's something, that's a value of 4. This is just something we've been trained. It's a symbol that we get trained to call something. So that kind of idea is what we call colors, is we get trained to call a pattern that we consistently see a certain color. Just like we are trained to call that A or call that 4.
So we technically have no way of proving if everyone sees colors the same?
As far as I know, we don't.
So technically, we could, so everyone's favorite color could be, say, red or something, but everyone sees red in a different way. So like, so basically like, say my favorite color is white, right? Well, it looks white to me, you know, but what someone else's white could also, it could be like a red or something. So, say this is how someone else's, like if, I'm not explaining this very well.
Well, no, I get what you're saying, because what your brain actually sees might be different, but what everybody's brain is receiving is the same as that wavelength.
Yeah.
So your body's response to that wavelength Kind of like yellow tends to cause a response, especially intense yellows, a response of dizziness or nausea.
Probably 'cause it's
Pink
really long.
tends to have a response of being calm, which is why that resource talked about prisons or mental institutions often painting the walls pink, because those people tend to be agitated, and something to trigger calming would be very helpful. So there is a physical and mental response to those wavelengths that there's a tendency for, and that's what is consistent for everybody, which we see something as white because all wavelengths bounce off of it. We see blue because only blue or that wavelength bounces off. So that's what everybody is seeing that's the same. What your brain does with it might be a little bit different.
Yeah, so like, what I was saying though is, so how I see red could be how someone sees blue, right?
Mhm.
So maybe my favorite color is blue because that's how I see, like, I see blue as like a red, right?
Mhm.
For someone else. Someone else's color favorite color could be red because they see red how, like, it's
Okay, I get what you're
supposed
saying,
to be,
yes.
you know?
Yep.
So technically everyone's favorite color could be the same thing, we just perceive it differently.
That is possible, yes. From that resource, did anybody catch what humanity's favorite color is? Blue. Could that be used for marketing and selling stuff?
Yeah.
If that's the color that most people tend to be like directed towards, pretty handy. Who caught what colors make you hungry? It's not blue. Red and yellow. Think about fast food
McDonald's.
logos. How many fast food logos have red and yellow in them? They're manipulating you. They're
Basically all of
brainwashing
them,
your brain to
actually.
make you think you're hungry when you're not. You see the sign and you're like, oh, and your brain that
Wendy's
responds by,
has
oh, I am kind of
red.
hungry. I'm going to stop and get that food. Look how
Chick-fil-A
nice and
has
convenient
red.
that is that they have food quickly for me, when they manipulated you into wanting it. Marketing, guys.
I'm pretty sure basically every fast food restaurant has either red or yellow.
They
in it.
do because they know that. They use the science to market
Chick-fil-A,
and get what they
Wendy's,
want from people
McDonald's.
and make you think you wanted it. That's how it works. A lot of money's made on that, guys. All right. So I think we've got color pretty good. Where did I put my notes? Does somebody see where I put?
There behind you.
So this is my seating chart. I had the other one that had. So I want to use that to make sure I'm
Did you put it down when you walked over there to write on the board?
probably. There it is. Perfect. All right. So now we're going to take a look at density. Let's see, which table did I start? It was back there, right? Okay, so I'm going to move to this table for density. Can I get one of you guys to share what you put for your definition of density? Thanks.
Like how close atoms are to each other.
All right, perfect. How close atoms or molecules are to each other. Most of you probably put something else, which, by the way, his is the most meaningful on the practical side of it, so that's super important, is how close the particles are. Somebody else on that table, was there something else that you guys put, maybe in addition to what he had? Because we definitely need his part. Most people have skipped on what he just told us. All right, can you say that one more time? There we go. Okay, so she had the two other pieces. To determine how compact something is, or how close the particles are, we have to look at how much space it takes up. Who knows what word that is in science? Volume. And how much stuff is there, or how much matter there is. Does anybody know what that word is? It's an M word. Mass. So it's the amount of mass or stuff in a certain amount of space. That tells us density, or how compact those particles are. So that kind of is the main idea. Is you will want to have how to calculate density. Did anybody from those resources get how we calculate density?
Mass over volume.
Mass divided by volume. How the ratio between how much stuff there is and how much space it takes up tells us, are the particles super, super squished and we have a high density, or are they super spread out and have a low density? Brick, the matter that makes up brick, squished pretty tight, which is why bricks are pretty heavy compared to a brick of styrofoam of the same size.
Oak is
Okay, and different woods have definitely different densities as well. Yes, because oak is, and that's why it works well for a lot of the building materials like it does. One more thing on description, which ties to kind of the practical meaning of it. So we've got the ratio between mass and volume. We have how squished or not squished the particles are, or compact. And then how does that tie to floating and sinking? How does that connect to floating and sinking? What do you got? Okay, sorry, I'm going to come over again. All right, the closer the particles are, is it just heavier? If they get closer, does the volume also change too? Because if they're getting smashed closer together, are they taking up less space?
Yes.
So the volume changes, and that's why our density changes too. Can you shut the door for me while you're at things? Because I want you to think about a ton of bricks. Does anybody know how much a ton weighs? How many pounds? 2,000 pounds of bricks. How much does 2,000 pounds or a ton of feathers weigh? 2,000 pounds. Would 2,000 pounds of feathers still squish you? Yes, it's 2,000 pounds. It doesn't matter that they're feathers. It's 2,000 pounds. Density? Well, not if it's on top of you. That would be 2,000 pounds of feathers that would be really squishing you. Now, being on top of them would be different. Okay, so the point is, density is not just mass. You can have very low density of things that are super heavy and will squish you. They're just, the particles are spread out a little bit more. So it's not just heavy. It's the amount of space. Kind of like a ton of feathers will smash you just as much of as a ton of bricks will. So now we have some of that meaning down. How do we use that to make our life more convenient or sell people stuff? The fact that some things might be more or less squished, or some things might float or sink based on their density differences. How can we use that? Yeah.
Some objects could be like harder to break than some others if they're close together.
All right, so if we're hitting with that, that's not necessarily a density thing, but more of a malleability, hardness thing, which we're going to get to in just a minute. For density, which actually, things that are more dense tend to have a greater hardness, not always, but very often. More dense have a greater hardness. All right, what do you got?
Like you can't sell somebody a boat that doesn't float.
Your boat has to float or nobody's going to buy it, right? The life jacket has to float or nobody's going to buy it, right? Now, before we get some of our own examples, can anybody share some of the examples that came from the resource that I provided? All right, what do you got? All right. Oil and water doesn't mix. Now, can that connect to oil spills out in the ocean? Can that be helpful when you're developing technology to clean up an oil spill? Because the oil's on the surface, right? And you can just scrape it off the top because it doesn't mix up with the ocean. So whether it's oil in a jar with water just for fun or for cooking, but very helpful when we've caused some problems and need to do cleanup. All right? Lava lamps. There we go. Which a lot of times it's an alcohol because it will repel a little bit more. But yeah, that's the idea is different densities allow it to work. And the heat can change the density, kind of like a hot air balloon. You heat up air, the air becomes less dense, and that's why the hot air balloon floats. And when they turn off the flames, it cools off, becomes less dense, and that's how they can go down and they control going up and down. So hot air balloon, good example. I'm going to show a few examples. How many of you guys use salad dressing? How many of you use salad dressings you have to shake up first? Why do you have to shake them up first?
Because the ingredients are different, like density, and so they don't mix very well for long periods of time because then they'll just separate again.
All right, different densities, they can sort themselves out. The seeds are more dense. Then we've got kind of the cloudy stuff, and then we've got the oil on the top. If you don't shake it up, you're just getting a whole bunch of oil dumped on your salad and not the mixture of flavors. I heard ketchup. Who said ketchup? Tell me about ketchup and density.
Like the water, like the, I don't know, just like the water. It
They
like
add
moves to
vinegar
the
to
top.
it.
Yeah, how many of you have been the first person to use the ketchup for a meal and you squirt out all of the juice instead of ketchup? And you're mad at yourself because you're like,
I-
dang it, I didn't shake it,
I should.
right? Or you let somebody else use it first so you don't have to deal with shaking it. That's what I tend to do. And I go, they can sort it out and then I don't have to deal with the juicy squirting all over my button. So anything you have to shake before using, there's a density difference for the ingredients and you need to mix them back up so it works right, whether it's salad dressing or ketchup or spray paint. Do you have to shake spray paint?
Yeah. For
What about
so
nail
long.
polish? You want to shake it up really good, right? Because you may not notice that some stuff is separated in your nail polish, but it has. That's why you shake it first to make sure it's all mixed up and it works properly.
You also have peanut butter. I have to mix my peanut butter.
Yep, and depending on the peanut butters, but ones that are kind of a more natural peanut butter definitely have that. All right.
There's this gif knowing to stir peanut butter. You have to stir that peanut butter more than regular peanut butter.
Oh, really?
Yeah, it's just funny.
That is kind of funny. Yeah.
So you have to shake whipped cream, like as in a can before you use it. But like what separates that?
So with that one, and I could be wrong, but I'm pretty sure that one is to get the kind of the aerosol or the gases that help make it foamy mixed up with the cream. So I'm pretty sure for whipped cream that's what it is it's the gas that makes it foamy and squirt out with the cream. Because if you don't shake it, it's super runny. And so the gases make it fluffy.
You have to blow on a wool flowy thing because it's dense when it's just the plastic outside, but when you put air in, it's lighter, so it makes it less.
Is it just lighter or is it less dense?
It's less.
Because the air can be super heavy, but it's less dense than the water.
There's more mass.
Yep. All right, good.
I was pretty sure with whipped cream that it's kind of like, you know how the soap in your like kind of like shampoo bottles or something
Oh,
goes
yeah.
to the bottom. I was pretty sure you shake it to kind of get it moving, and whenever you go like that, it actually goes to the top, and then like you can just do it, and it actually does that. And I was pretty sure that like if you didn't shake it, the reason that it doesn't come out is just because it's still stuck at the bottom.
Yeah, and that could be depending on the design of the canner. But I know whipped cream in general, you have to get the air bubbles trapped in it to make it foamy. So it's probably a combination of both. I know a lot of spray cans, they've got tubes openings like at the top and the bottom, so whether it's standing up or upside down, it'll still spray. But some cans will say has to be upside down or it has to be straight up, and that's just depends on where the opening is to suck up the stuff. But yeah, so there's a lot of different designs that those things do apply to. So last thing with density, I want you guys to tell me about my balloon. What does this product have to do with density? What do you got, Joseph?
Helium is less dense than air.
And how do you know?
Um,
So it is less than dense than air. What are we observing?
Oh, it floats.
It floats. So something as simple as a helium balloon. It's a product that makes lots of money every year just to make a little bit more of an entertaining decoration than the balloon you fill up with the air out of your lungs that sits on the floor. What do we know about the density of this stuffed tiger?
It's more dense than the air because it doesn't float.
All right, it drops to the ground, right? Do people spend money buying things to attach their balloons to so they stay in place?
Yeah.
And do those things have to be dense enough that it holds it in place?
Yeah.
Or use strings to tie it to keep the thing that wants to float away? So something as simple as that makes a lot of money, a product purely based on density. All right, just because, I'm gonna have you guys hold off your questions in case we have time at the end, because you guys are having amazing questions, but we're not making it very far in the review, and I wanna make sure we get to some of the more complicated ones and not run out of time. So make a note of your questions and we'll try and come back to them. All right, so let's move on to our flammability. This is a fun one, but we're gonna go pretty quick on it. This one I just wanna volunteer. Who can tell me what flammability means? What does it mean?
Like able to catch on fire or yeah.
Yeah, it's not any fancier than that. Can it burn or not? That's flammability. So, what did you learn about pajamas from those resources and flammability?
They have to make them more flammable
we want stuff that's more flammable for babies?
Or less one.
There we go, okay, just check it. All right.
Burn the
We
children.
do not want to put our babies in more flammable stuff. We want to put our babies in less flammable stuff. Which it's a law, by the way, guys. It's a law, and that's why, and I know you're not parents yet, and you probably haven't paid attention to the tags on your pajamas when you were a kid, but there's big paper tags that people pull off most of the labels within the clothes for pajamas. By law, have to have labels saying that they are made of a flame-resistant material or have been treated with something flame-resistant, because it's just something that has been decided is very important to make sure, at least for children's sleepwear. That's very important for firefighters and the stuff that they wear, or people that are in those kind of things. A lot of people, how many of you guys have used bug spray? Have you ever read the warning labels for bug spray?
I've made a flamethrower out of
It's very flammable. My dad forgot about that one time when we were camping in Oregon, and they've got mosquitoes like crazy. So he coated himself, went and lit the campfire, burst into flames. Because the alcohol that dispenses the bug spray hadn't evaporated yet. Luckily, the dirt and stop, drop, and roll worked and just singed his eyebrows a little bit. But a lot of stuff has flammable things inside, and those warning labels are to help keep us from that happening. I'm going to do one quick demo just because it's fun to light stuff on fire. Let me make sure I've got all my stuff tracked down. How many of you guys have ever used the little packets of the Magic Fire stuff? You haven't seen it? That's what I'm showing you today. Another product that makes fires even more entertaining than they already are.
Fire is fun.
It is a lot of
I
fun.
don't know why. It's just fun.
It is, like, yeah, half the planet's pyros.
Lighting stuff on fire is just fun. If you don't find it fun,
And I'm pouring some alcohol on it, one, because you know it's fun, and two,
just light your hand on
it'll help it burn a little bit
That's
better.
so
Or
fun.
you can just burn your hand off.
Oh,
I lit
Then
my
you don't know
homework
what to do.
on
You
fire.
just like,
there we go.
What the heck?
It's green. And
We got some green and blue and yellow.
how long does it
You
burn?
can do that with like seawood, like when it's all dry, like beech wood.
Yep.
You can do that with
Yeah, it's because
Because
of the
different
salt.
chemicals burn different colors.
Yeah, salt burns green,
Wait,
so
is it-
the salt water
does the
that's in
copper
the
make it
wood
green, or
is
Yeah, you can put a copper pipe in and blow air.
Yeah,
through
there's, and I can't remember, I looked it up once, but fireworks, have you noticed there are a lot of different colors?
yeah, they have like salt
They use
and
specific
phosphorus
chemicals to make the different colors. So they basically took fireworks with a less explosive part, put it into a packet and sold it to people. So it wasn't anything new, it was just the non-explosive part of a firework.
something about fire is just fun.
It's very mesmerizing.
Oh, okay. Have you ever touched fire though? It feels like water,
Yes.
like dry water.
I put like
Like you run your hand through a flame, and it feels like you just kind of like stuck your hand in water and then came out dry. Yeah,
You can put a
exactly.
Mac in your mouth to extinguish it, and you can also be an idiot.
Which, can you do that? Yes. Is that always the smartest or safest thing to do?
Definitely.
Absolutely not. And I heard some people talking about using cans and lighting the stuff on fire. Guys, you are lighting off a bomb in your hands. That is dumb. The stuff that you're spraying is flammable. Guess what? The flames can go inside the metal shrapnel, basically a grenade that's going to explode in your hands.
Really?
Is that smart to do? No, that is stupid, guys. Could it be entertaining? Yes, but very, very, very stupid.
If I made a
Okay, guys, we're not going to engage in all of the cool, stupid things you could do. Because there's a lot. It's easy to do that list. But guys, think first. Is it worth the risk of burning some stuff shooting out of here in hopes that you don't explode a metal shrapnel in your hand that'll make you lose your hand and who knows what else? Please don't. If you want to burn stuff, do it in a way that's not a grenade in your hands. All right. So we are going to move on to what hardness actually means. If you remember, this squishy stuffed animal. Yes, it's super squishy. That is not what hardness means. Who can share what it actually means to science? Jace.
Is it like how easy it is to get scratched?
It's the scratchability, not squishiness.
Yeah,
Resistance
malleability
to
is-
scratching.
is
All right?
the squish part.
So, if I took this nail, could I go around and scratch up a lot of stuff in this classroom?
Yeah.
Yeah.
From the tables to the books to my computer, I could scratch up my phone screen like crazy, right?
The keys.
Depending on how good my screen protector is, right? So if I try and scratch up the fabric that this is made out of, is it really doing anything?
I mean, if you go harder, it would.
So add pressure, but I have attacked this poor guy for several years and I'm pushing pretty hard on there to try and scratch it. Are a lot of flat fabrics resistant to scratching? Does that get used for a lot of outdoor clothing? So it doesn't get torn and snagged and that kind of stuff when you're out in the woods and that kind of thing? Pretty important. Just with basic fabrics, right? Now, how many of you guys have used crayons before? You don't have to admit whether it was last week or in kindergarten, but how many of you scraped off half of your crayon with your fingernails?
Oh,
Yeah, and then it gets stuck underneath your fingernails and then you got little flakes everywhere. What is harder, your fingernail or the crayon?
fingernail.
Your fingernail. What is harder than your crayon, or which is harder, your crayon or the paper you're coloring on?
Paper.
Which one is scratching off the other?
Paper.
Paper is scratching off the crayon, right?
Alright, that's so weird.
And you use the crayon on paper, very practical
So then the
product.
paper is harder than graphite too?
Paper, why would paper be harder than graphite?
Because it scratches off
It scratches the graphite in your pencil lead, right? How many of you guys, and I forgot my sidewalk chalk at home, so I just got regular boring chalk. How many of you guys have used sidewalk chalk or chalk before? And have you scratched it off and kind of carved it up a little bit? Some of you have.
If I use a
Have you
pocket-
drawn on the cement with it? Which one is harder, the cement or the chalk? The cement, because the cement scratches the chalk. So something as simple as crayons and pencils and chalk, they're all about being able to, that scratchability on the specific surfaces you're trying to leave the stuff on. So it can be a super simple connection. Let me just make sure those are the main ones. Did anybody from the resource I provided you get anything about tools like drill bits and saw blades? What did you get?
Tools need to be harder than most stuff so they don't scratch when you're trying to do something.
Right? Because you want them to scratch the stuff you're trying to drill through or cut through, right? So wood is what we often, or sheetrock, try and drill or cut through. So steel that has a hardness on a scale of 1 to 10, about a 7. It's going to easily drill through or cut through our wood or sheetrock that's at that 2 to 3 or 4 to 5 range. But if you're trying to cut through other metals, could that cause a problem? Because they have the same hardness, right? Really wear out those blades. So what do they do to help those blades be a little bit stronger? What do you got? Yeah. I'm not letting people do hall passes today because I just want to make sure we're here for the whole discussion.
I just have a question.
All right, I'm going to hold off your question just for a second because I want to make sure we finish off the blade drill bit thing.
They use diamond bladed saws.
They're diamond bladed saws because how many of you guys read that diamond is the hardest substance that we know about? Yeah, that's a 10 on that 1 to 10 scale. So diamond's going to be able to cut through pretty much everything.
So I could sell my saw blade for a whole lot.
Well, it's not solid diamond blades. It's not solid diamond drill bits. What's actually more effective is tiny pieces. So you've got a whole bunch of kind of grit.
And then melt it down and then put it with like iron.
It's
or
got a
something.
really high melting point, so the diamond won't melt, but when they're forming the blades, when they get the metal soft, it'll basically embed the diamonds in it. So when you go to the hardware store, you're gonna see a range of prices for your drill bits. The ones that are basically just the still, like if it's just a regular saw blade, those are like $10. If you get ones that are carbide tipped or titanium tipped, some of that extra strong metals added to it, those might be like an extra $5, maybe $10. But if you get the diamond bladed saws, which by the way will last like 4 or 5 times longer, cut through so much more stuff, they're like 10, maybe $15 more than the cheapest ones, but they last way longer, cut through a lot more stuff. Because the diamond is not going to get worn out nearly as quickly because it's more resistant to scratching than just the regular metal. Yes? Yeah, you.
Looks like a 10 on the hardness scale.
Yes, yeah, diamond is a 10 on the hardness scale.
No, but is that it?
That's, as far as I know, that's the only thing that's at the 10. I can't remember what, but it seems like there is something at a 9.5. I just can't remember what it is. But yeah, diamond is the hardest one, which diamond can only be cut by other diamond, or they can use plasma, which is basically kind of a laser type thing, to cut it with rather than a material to cut it with. All right, what was your question or comment?
Oh, I was just gonna say, like with the diamond blades, how would that work? Because there's only flecks of diamonds. Like, so wouldn't the blade just get dull really fast? Because it, like with tile, like you're cutting the tile, but the metal blade's also in contact.
Yeah, and it still will eventually wear out, but the diamond that's embedded into the blade, because that's kind of what's touching the stuff you're cutting first, it'll have to wear through that diamond first before it starts wearing through the metal. So that's a very valid question. And then just a second, it seemed like there was one other piece that I wanted to add with that, and I can't remember now. All right, any other last couple questions? So I'm gonna go back to phone screens. Is that a product that a lot of people spend money on? Is scratch-resistant phone screens? Tons of money gets spent on that. A product, because people have their phones all sorts of places, in your pockets with a lot of other stuff, in your purses with lots of other stuff. Easy to get scratched. Products take advantage of that to help make your life a little bit more convenient. All right, malleability. Who can tell me what you learned about malleability? I want someone who hasn't participated yet. So I've got quite a few hands. That's right, I don't think I have to read it.
It's the ability to shape something without breaking it.
All right, she hit an important part that most people left off. It's not only being able to shape something, but shape it without breaking. For example, I can take this pencil and I can snap it in half. I reshaped it, right? But did I break it in the process? This pencil is not malleable, and I've broken it enough. That was kind of hard. I'll have to get a new one. So it needs to, the word that was in a couple of the readings was deform. So it needs to be able to deform under pressure without breaking. So that's where we've got our malleability. So I just showed that a pencil is not malleable. So hammers are helpful for applying pressure. So we're going to try using our hammer on some stuff to figure out what's malleable or not. And I need to go back. I'm sorry. Need to get some new stuff real quick. Alright, so I've got an ice cube. What do you think this ice cube is going to do under pressure? Is it going to just deform or is it going to break? Let's find out. Some of you predict it's going to break. Did it shatter pretty good? Just in case you didn't see it. Did it shatter?
No.
Is ice malleable?
No.
No.
Yes. Well,
It broke under pressure, so it has to be able to deform but not break under pressure.
can if it melts.
So can temperature affect malleability?
Yes.
Yes.
Like
One of the
heat
readings
metal
talked
makes
about zinc definitely becomes more malleable. If you read the one, did you guys read about the blacksmithing?
it. Yeah.
And that's, blacksmithing works on that. A lot of metals, not malleable, but if you heat them up, they can become malleable. They can form the shapes to make the axes or the knives, or back in the day, or if you really like swords now, to
I
make
love
swords.
I love swords.
And then when it cools off, it loses the malleability and then it works as a weapon or a tool. So malleability can change based on temperature, depending on the material. Some keep the malleability no matter what. What about my snow leopard? Yes, I'm going to try and smash them with a hammer. It's great. Hammers are almost as much fun as fire is. Well, it depends on what you're doing with it. Destroying stuff, demolition with a hammer is a lot of fun.
If you're breaking it,
So, what do you guys think? Is a stuffed animal malleable?
Yes.
No.
It has to deform and not break, so let's smash them with a
yes,
hammer.
it is malleable.
Am I deforming or changing its shape?
I don't know,
Yeah, it moves down, it
Yeah, but it
deforms,
comes back
and then it
up.
comes back, exactly.
but it's not deforming.
in the process.
Yeah, it deforms in the process.
But it doesn't
Yeah, but it just
stay.
comes right back up.
Okay, so good discussion right there, a debate, which is getting to super technical parts of malleability. So, as I am smashing it, yes, there's some deformation, but because the elasticity, which is a different property, do you remember when we learned about elastic potential energy? Things want to return to their shape. So because the elasticity, it goes back to shape and doesn't maintain the deformation. So in a technical sense, he's not malleable because the return to shape or that elasticity.
So
However,
then rubber wouldn't be malleable?
depends on the type of rubber, but most rubbers, well, yeah, it depends, because some rubbers are more moldable than others. So it just kind of depends on would it break when you have the pressure. So what's this? Play-Doh. What? It is. Is that a product that is awesome because it's malleable? It easily deforms and doesn't
Soft,
break.
too.
A lot of money in this product, right? How many of you guys have been in a ceramics class or done much with clay? Are all clays the same?
No.
Are
not
some
at all.
more malleable than others?
Yes.
Based on that, do you use it for different types of sculpting or different types of ceramics? Absolutely. So something as simple as slight malleability differences in clay have a lot of variation in how they're actually used with sculpting on different stuff. So last one is this stuff. How many of you have used this stuff before?
Yes.
All right, what is this handy for?
Wrapping.
Wrapping up stuff, particularly food, right? Now, some of the readings talked about, yes, it's deformed under pressure without breaking, which means it can be formed into thin sheets. Aluminum foil is a good example of that thin sheet. Talked about gold being formed into sheets that can be used for other stuff. So they pre-deform it for us, so then we can deform it a little bit more and wrap it around stuff. Now the fact that it does not react with water or a lot of other stuff in food makes it safe to wrap around our food. Which leads us into our next property of reactiveness to water. So we're going to take a look at that. Who can tell me what reactivity means? Get a lot of the same hands, guys. We need to get some good variety going on. Joseph. All right, now I'm going to add one word to what he said. If there is a chemical change when it interacts with water. Because some changes like freezing, that's not a chemical reaction, it's just a phase change. So if there's a chemical reaction when it comes in contact with water. So that's an important thing. How many of you guys looked at the video about sodium? What does sodium do in water? It blows up, right? Extremely explosive, extremely, and very violent explosion, which is fun to play with sodium. Kind of scary because it's just a tiny bit, very explosive. But would you want to touch pure sodium with your bare hands?
Why?
Why not?
Your hand will explode
Why would our hand explode?
because there's water.
Do we have moisture on our skin?
Yes.
Yes. It's important to know what has water in it, even if it's a little bit, what might react and explode violently with contact with water like that sodium. Which is why sodium has to be stored in oil because oil will repel water to make sure that it doesn't blow up as it's being stored. Hopefully you guys took the time to look through the list of water-sensitive chemicals. And as you read through some of those, some will just boil, some will have a violent explosion and create hydrochloric acid. So if something explodes and creates an extremely strong acid that will eat through skin and a lot of other stuff, could that be a serious problem? Yes. Absolutely. If it explodes and creates hydrogen gas that's extremely explosive, could that be an extra problem? Double explosion, right? Unless you're wanting to blow stuff up, could that be very helpful? Absolutely. So demolition needs to know some of this for safety stuff and blowing up stuff. Certain places that use some of these products You need to make sure they're careful with that. See what time we at? 28, and we're done at 30 today, right? Okay. So, the last few things we're going to do very quickly on Monday because we're not going to take much time on them. But